All right, hi everybody. This is the lesson on u-substitution, and this video includes examples 1 and 2. The next video will be examples 3 and 4. So what we have is a situation where we look to do an antiderivative or an integral of something that potentially looks like a chain rule or product and a quotient. And these are a little bit more challenging to actually integrate. So what we can do is use another strategy. And this strategy is known as u-substitution or u-sub. And what that means is we're going to be doing a substitution back into the integral of a couple of things. So the first thing that we need to do is to identify what our u expression is going to be. And so we're going to take a look at under a root, raised to a power, a denominator, an exponent with e, and a natural log. Now, just as a quick fix, you guys, this little part that says quantity, it should actually be expression. All right, we're going to look at the expression under the root and so on. So, taking a look at example number 1, we can see that this is raised to a power, this expression, as well as the 8x, and it looks kind of like something that we would undo a product rule, but this is actually where we are going to do a u-substitution. So this expression within the raised to the power of 6 is what is going to be our u-sub. So we are going to take the derivative of that expression, that equation, and again, we are going to take the derivative of the u on the left, which is represented by du. We're going to have an 8x, and since we are taking the derivative with respect to x, we're going to have the dx, and the 8 would be 0. So that would be the first thing we do is identify the u, and then we differentiate it. Now, in order to do our substitution, if you take a look, we have where this expression right here, and we have this d of x that needs to be substituted as well. So we need to isolate that d of x, and when we do that, if you take a look at this algebra, we'd be dividing both sides by 8x. So what we have is d of x is equal to du over 8x. Now, we're going to turn around and do some substituting. Then u-sub, we're going to substitute a u, and we're going to substitute the d of x as far as the d of u. And what this is going to do is allow us to see, what do we have? 8x, and our u, that expression, is being raised to that power. And the d of x is now going to be the du over 8x. So that's now what we integrate after substituting just the u and substituting this, that would have been the d of x. So if you take a look, our whole idea here, you guys, is to eliminate these x's and just have things in terms of u, which is a little bit more straightforward way of integrating. So we have that 8x in the numerator, that 8x in the denominator, and that goes to 1. So we are left with this function that we need to take, this derivative that we need to take the antiderivative of. Now this is just the power rule, which is one of our rules that we have learned. And we are going to have the function, and again, we're going to have this eventually in terms of x, and it's going to be u to the 7 over 7 plus c. Now, we're going to put this back in terms of x, and we are going to substitute that u expression. What was it? U is 4x squared plus 8. And that is what's going to replace the u inside of that function. Which means our final function for this, in terms of an indefinite integral, would be the u we're substituting back in to the 7th power over 7 plus c. That would be our indefinite integral of a problem that is a little bit more involved than what we've seen. All right. Okay, example number 2. So if we take a look here, underneath the radical is this 3x to the 4th plus 10. Now, so that's going to be our u. Again, we're looking for expressions that could possibly like undo something that looks like a chain rule. So now we have to differentiate this u. So we're going to get d of u, and we're going to have 12x to the 3rd power, and the 10 again goes to 0. We're going to have that d of x. Now let me just emphasize, our goal is to substitute our d of x for the expression that we get for that as well. So we need to isolate that d of x by solving for d of x. And again, you guys, algebra 1, that all is being multiplied. We have to divide. So we end up with our d of x equaling to that du over 12x cubed. So now we are going to do our u substitution. We still have the x cubed. We're going to have that u representing that expression, but the thing you have to remember, this is an x squared. So the way we write that is 1/2. And our dx is du over 12x to the 3rd power. Now, we can integrate this. First of all, let's look. An x cubed gets canceled out with x. That x cubed, it goes to 1. We are left with that 12 in the denominator. I'm going to write that out front. And this is what we have to integrate. And we know from a situation like that, we are doing the power up rule. So we would have 1/12 u to the 3/2 being divided by 3/2 plus c. Let's just go ahead and write our function notation. So to simplify this, we have the 1/12 and we have the 3/2. Do the reciprocal and multiply, and we should end up with, what do we get? We should end up with 1/18 u to the 3/2 plus c. Now, at this point, we can substitute our expression for u. What was our expression for u? It was let's look up here, 3x to the 4th plus 10. That is going to go right where the u is. So our final function is f of x is equal to 1/18, and we are going to have our u raised to the 3/2 plus c. So again, you guys, what you want to be careful of is a couple of things. Be sure and identify the expression underneath the radical. Be sure and isolate that d of x so it can be substituted. And then you're going to be doing some simplifying, which is this right here, those x cubes, and then get to something that we can turn around and take the integral of, which we should be comfortable with that, and then you get to your solution. Examples 3 and 4 are going to be in the next video. See you next time.